screen right now. Should I start?
Hannah, can you see? Perfect, yes, very good. Let's start. Thank you.
Our topic is number 8, and the header is synchronization and analysis of the biomarkers under noise and stress. So all of the students here are really familiar with the topic, because when we have been in the Kuopio University Hospital, you have done something similar to these tasks. First, I will try to inform you about our data collection methods and the data sources we have used, and then I will show you our visualization methods and some results of that. Here we have used 21 participants MP4 video file, and then we annotated frame by frame, and we created a data set. So this was taken a lot of time, because always the pre-processing takes a lot of time. And we have been working with also the experiment outcomes analysis data and physiological data, which are provided in ASC files. So I already included them in my project report so that you can investigate in detail also. And tools that we use, for example, for video annotation, we both use Boris and Tracker. These are just software to annotate videos frame by frame so that we can just extract them according to some movements of the participants in the video. And I also use the Jupyter Notebook, Kaggle, Matplotlib, Seaborn, and Plotly libraries to visualize the data of participants. And our purpose is by extracting the frame numbers, making them nice visualizations, for example, how long each task taking for each participant, or how the mental demands, physical demands, task complexity and distraction changes for each participant when they both work in a silent environment and noisy environment. So we were trying to investigate these effects on each participant. And I already mentioned about the methods, so I just want to show you this movement tasks. So in each video, our participants were dealing with a 3 subtasks. These are mesh alignment, knotting, and going around. So each of them have a start frame and ending frame. So when we see them for the first time, we call them pre-exposure, and the second time exposure, and the last time, the third time, is post-exposure. And we extract the frame numbers, and we created this Excel table.
Okay, yes, good.
Excel table, and we put the starting and ending frame numbers to there. Dr. Antti provided a skeleton for this Excel table so that we have used it. And always when I started before I started doing some visualizations, data immersion and problem immersion is important, so that I made some visualizations to understand what data trying to tell us, and then I made some comparisons and results section. Here, for example,
Yes. Is it this?
Yes, this is a bit small, but I hope you can see. For example, this is from our experiment outcomes analysis data. I just cleaned and pre-processed the data to do this visualization. For example, here our group by attribute is condition, noise, and silent. The blue dots are noise environment participant, and the orange dots present silent environment participant. For example, in this visualization, this is really wide, so we can just see all of the attributes and participants together in one visualization, both by using scatter plots and density graphs. And yes, this is the data frame that I used. Here, each participant has some date, gender, ID, condition, or the order of the task they have used in exposure, pre-exposure, and post-exposure, and their physical demands, temporal demands, task complexity, and the other attributes. Since they're too big, I just couldn't put them all in the presentation. And then I created this heat maps. So this shows the correlation of the attributes in the data set. For example, this is that doesn't mean that they have some linear relationship, but for some reason, for example, if we increase the task complexity, then the physical demands also increasing. So how we can understand this by using this table? The lighter, when you go the lighter in the dark, that means that the correlation increases. So we can just look at this heat map to understand which attributes have some correlations with each other. So I just extract some of the attributes to show you better here in this smaller heat map. Again, you can see the correlation, high correlation between the physical demands and again mental demands or distractions, or the things that they don't have any correlation or less correlation again. So this is for noise environment participant, or we can also visualize for the silent environment participants, and we can again investigate the correlations. This is just one way of investigating the correlations in Python. So, and then we built a data summary by using R. Actually, there is an automatic way to do this data summary tables both in R and Python, but you can do it manually by calculating those things by yourself if you want. But there is an automatic way to do this, but just to understand, I also built a data summary table in R. And again, I created some visualizations. These are pie plots, shows each participant individually. For example, which participant needs temporal demands at most, or which participant has physical demands or other demands at least. We can see clearly when we look at them. And I created also a 3D dimensional visualization, but since it's not interactive, I'll try to show you by using my IPython notebook here. For example, if you want to see or investigate the relation between three attributes at the same time, we can use three-dimensional visualizations here. Here, each dot presents one participant. So when I click on that, I can see the ID of the participant here. And I can say, for example, I can comment on that participant that he needs really much temporal demands and less mental demands, and again, less physical demands, or we can see each participant by clicking on that. This is three-dimensional way to investigate each participant in Python again. So I also did this for the silent environment participants. Yes, and let's go on. So, yeah.
Is it here?
Yes. After that.
Yes.
Yes. This is also an interactive data visualization to investigate each demands of each participant again. So I can also show it to you. So again, when I come to its each participant, I can see them one by one. So this is a good way to see each participant demands when you have a big data frame or big data large data. And okay, let's go on. So yes, this one. Go on. Yes.
Yes, that one. Yes.
So this shows a box plot. A box plot provides you to see mean of the both noise and silent environment participants and their spreading out area. For example, if we want to make comment on that, we can see clearly again easily the silent environment workers are always need less mental demand, so that they are at the bottom spread out. And the noise participant, how can I say, again spreading out at the high stages or levels, and they are mean also always much more than the silent environment participants. And I also visualize them in a density graph, and in this visualization also we can see the p-values and r-values for each participant. So there can be a lot of visualizations, and I want to show you my data summary tables. For example, here for the noise participant, you just can get a data summary table by using just one line of code, the describe method, and then you can see the